Hey guys, today we're going to do Unit 8, Lesson 3, which is inverse variation. This is something probably brand new that we've never heard of before. So I've pretty much typed it all out for you. So we've already learned that solving equations, we know that squares and square roots are inverses of one another. And so when we're talking about their functions are also inverses of one another. Okay, so in order to find an inverse function, what we're going to do is we're going to swap the x and y variables around and then solve for y in the new problem, and then we'll have a new function. Okay, so in Math 1, you did learn about the vertical line test. The vertical line test determines for us if a relation is a function by drawing a vertical line, and if it crosses through the function more than once, it fails the test and it's not a function. But if it just passes through that function one time, then it does pass, and so we have a function. Well, there's also a horizontal line test. The horizontal line test determines if your inverse of a relation is a function or not. And so for this quadratic, when I do a horizontal line test, it fails because it crosses it twice. Okay, but for this square root function, it passes because it only goes through it the one time. Okay, so let's jump right in with an example. Okay, so we're going to explore the graph of this quadratic function, x squared plus 12x plus 38. So I have already filled out the table of values for this quadratic function, and I've graphed it right here. What we're going to do now is we're going to find the inverse relation, and we're going to determine if that is a function. Okay, so what we're going to do is we're going to take all these x values from the original function and we're going to move them over to the y value spot. And then we'll do the same thing with the y values of the original function and put them in the x value spot. So instead of negative 9, 11, I now have 11, negative 9. Okay, so all my y values here become my x values here. Alrighty, and now let's take all these x values and move them over to the y side of my table. Okay, so that is how I handle it with a table. Okay, my next question is the inverse relation a function, yes or no? So here's what we're going to need to do. We're going to need to plot these points and do the horizontal line test to determine that, okay? So let's go ahead and do that. X is 11, y is negative 9 over here. Okay, x is 6, 1, 2, 3, 4, 5, 6, and then down 8. 8, right there it is. Over 3, down 7. Over 2, down 6. Here it is. And then I'm going to start moving back up the other side. All right, so here is what I get when I plot these points now. So let me just zoom in on this, and we are going to connect these points. Okay, and so is this a function or not? You can pick any spot and draw yourself a horizontal line, okay? So my horizontal line, and this is a function. This is a function. because it passes the horizontal line test. So is the inverse relation a function? The answer is yes, it is. Okay, it passes the horizontal line test. Okay. And then I just wanted to ask you, what does the inverse function remind you of when you look at it? So this is a quadratic, and I get a parabola shape. This kind of looks like a parabola that's been leaned over on its side, right? But what would happen if I took away part of my picture and that's all that I had right there? What does that look like to you? It kind of looks like a square root function, okay? So a square root function really is kind of just a parabola where half of it's been cut off. So two square root functions that are together. That's kind of what the image shows me. So let's take a look at what is the difference between the domain and the range of both of these functions. So of my original parabola, I know that my domain is all real numbers because it goes left and right forever. So all real numbers. What about the range? Well, the range up and down, the range starts at +2 and it only goes up. So the y values are greater than or equal to 2. Okay. Let's look at our domain and range of our inverse function. So the domain, again, these are the x values left and right. This is at x equals +2, and it doesn't go left at all. It only goes to the right. So now my domain is x, the x values are greater than or equal to 2. And now my y values up and down, it's going to continue going up forever and down forever. So this is all real numbers. Okay, so take a look at how the domain and range become opposites of one another. Okay, now there is an extra note down here. The graph of the original function and the inverse is a reflection over the line y equals x is what that should say, y equals x. And so I drew that line y equals x for you right here. Okay, and this is the inverse function of x. So this was the original, this is the inverse, and you can see that it is a reflection over this line right here, this diagonal line, which is kind of neat, okay? So this is how we do inverse variation when we're starting out with a table and how we can graph it and looking at the domain and range and checking to see if our new relation passes the horizontal line test. Okay. All right. Now, what if I didn't start out by using a table and a graph to look at this and compare it? What if all I had was this function? Okay. So we're going to do the same thing if all we have is the function. We're going to swap around the x values with the y values. So let's go take a look at an example of that. So this is my original function, okay? Remember that f of x is the same as y. So y equals, okay? So those are my y's, or at least that's my y's in the original function. I'm trying to find my pink highlighter. but I don't seem to have it. Alrighty, I guess I'm just going to use yellow. So, right. Okay. So I am literally swapping around the y values and the x values. Okay, and so what I've done is I've created this brand new equation where I now need to solve this to get y by itself so that I know what the new function looks like. Okay, so the first thing that I'm going to do is get my pen. There it is. Okay, so I know that I've got this y squared and I've got a 12y. So what I'm going to do is I'm going to subtract this 38 from both sides. So I have x minus 38 equals y squared plus 12y. My a value is 1 and my b value is even. So it's going to be really simple for me to solve this by completing the square. So I need to take this 12 and do half of it, and then take that 6 and square it. Okay, so remember, the 36 is what I'm adding to both sides. But then when I factor this, I'm getting y plus 6 squared. Okay, so because I'm adding 36 to this side, I also had to add it to this side, just sort of as a reminder. And so now let's take a look at what we've got. Negative 38 plus 36, I have x minus 2 equals y plus 6 squared. All right, so the only thing left over here is this squared binomial. So let's square root both sides to get this by itself. Okay, and then don't forget that this is a plus and minus here. And so final step to get the y by itself, I need to subtract 6. But I want to put that in front of the square root just to keep the formatting proper. Okay, and so this is my inverse function. This is my inverse function. Y equals negative 6 plus or minus the square root of x minus 12. And so now I started with this quadratic function, and now I have a radical function. All right, so let's talk about briefly, some things need to have a restriction on the domain, okay? When you have like parabola functions, you can restrict the domain so that your inverse function for a portion of the graph, it's gonna like cut it in half. So I'm gonna show you that. So we're looking for the part of the graph where I can just slice that graph in 2 equal parts, and it will definitely make it become a function. So let's look at how we do this. What I'm going to do is I'm going to find the axis of symmetry. Remember, with a quadratic, the axis of symmetry is this line that goes through the vertex and cuts it into 2 equal parts. So, given my original equation up here, where is it? Okay, my a value is 1 and my b value is 12. So let's plug this in. And then simplify. Negative 12 divided by 2 is negative 6. Okay, so if I cut this parabola into two equal parts, and I say only look at the values where x is less than or equal to 6, and the parts where the x value is only greater than or equal to 6, we end up with this, right? The greater than values for x go that way, and then the less than values for the x go to the left, okay? And so I've just cut my function into two equal parts, which makes it so that when you do flip it over and you get this, that if you're only looking at half of it at a time, it's still a function. And then just one more thing about the reflection piece. This line that it's being reflected over. It's just sort of an important note that if you put these functions together, which you don't know how to do yet, we'll learn that in tomorrow's lesson, but if you compose these functions and you put them together and then you simplify, the result will be y equals x, or 1x, which creates this this line y equals x that it happens to reflect over, which is kind of neat. Okay, so at the bottom of our paper, I do have a little bit of room, and I just want us to do an example or two, okay? So let us find the inverse function of y equals 4x plus 1. So in this example, I'm going to use a linear function because you can do this process with all functions. So example 1. So here's what I'm going to do. Wherever I see the y, so this will be my inverse function, okay? Wherever I see the y, I'm going to put an x there. Wherever I see the x, I'm going to replace that with the y. And now what we need to do is solve this to get the y by itself again, like it kind of was when it first started out. So let's subtract 1. So I have x minus 1 equals 4y, and now I have to divide by 4. And so here's my inverse function. Y equals x minus 1 divided by 4. And notice it's really the exact opposite of what we originally started with. Instead of multiplying by 4, I'm dividing by 4. Instead of adding 1, I'm subtracting 1. So you can do this with any kind of function. All right, let's just do one more. We'll do one more, and then we'll call this a lesson. So let's now find the inverse. Let's see, I'll say g of x equals 2x plus 1, the square root of x plus 1. So find the inverse function of x, okay? So here's what we're going to do. We're going to swap these around. So now I'm going to have x equals 2 square roots of y plus 1. And now I'm ready to solve. So let's divide both sides by 2 to get the radicand by itself. Okay, now to get rid of this square root, I'm going to need to square both sides. So x over 2 squared, and that now equals y plus 1. Okay, and now I'm going to subtract 1. So let me simplify this too. X squared over 4 minus 1 equals y. and this is our inverse function. Okay. Alrighty. That's it for today, guys. I know it's a little weird. It's a whole brand new topic that you've never heard of. But it is just finding the inverse of a function. Okay? So just remember these notes here. Switch the x and y variables in the original function, and now you have a new function, and you're going to solve for y, and the result is the inverse. Okay? All right, until next time.